A warm welcome. This is Electric Energy Generation, Utilization and Conservation course with lecture 3.5 focusing on welding generator. A generator normally converts mechanical energy into electrical energy. Similarly, the welder generator will generate the electricity adequately necessary for the welding purpose. And in this case, we need not rely upon the main electricity supply. Just like while you are filling the fuel tank and running a regular generator, the welder generator will power the welding equipment whenever and wherever it is needed. There are two main types of DC welding generators, namely opposition series generator and split pole DC welding generator. When considering the opposition series generator, it is further classified into two types based upon the excitation, namely separately excited generator and self-excited generator. First, let us see about the separately excited generator. Here, the generator has two field windings. One is called the separate excitation field, which produces a constant magnetic flux. Here we can see it is phi m and is energized with the alternating current through a resonant voltage regulator and a silicon rectifier. Both will be mounted on the generator frame itself. The other one is known as the opposition series field and is placed in series with the welding circuit. Here we can see it is at no load, there is no current flowing through the series field winding and the EMF of the generator is solely due to the magnetic flux phi m. When the welding circuit is completed and an arc is struck, the series winding produces a varying magnetic flux phi naught, which will oppose the main flux phi m. With the increase in the welding current, the effect of opposition series field also increases and hence the total magnetic flux is decreased and the terminal voltage of the generator will be brought down. When there is a short circuit, the two magnetic fluxes will become nearly equal in magnitude and hence the total magnetic flux will collapse and the terminal voltage of the generator drops to zero. Thus, the effect of opposition series field is one of the main thing to produce the drooping voltage ampere characteristic. Welding current can be adjusted continuously by varying the main flux phi m with the help of this varying rheostat RH. Next, let us see about the self-excited opposition series generator. Here, as we see the circuit diagram, we can see that the field winding is energized from one half of the armature winding of the generator itself. This is why there is a third brush known as the brush number C. Already we have A and B brushes. Here we have C brush between the main brushes A and B. For that reason, it is also known as third brush generator. Under load, the voltage between the brushes A and C remains practically constant and the self-excitation field winding connected across the two brushes produces a constant magnetic field phi m. When the arc is initiated, the the welding current flows in the series field winding connected so that its magnetic flux phi naught opposes the phi m flux. The larger the current in the welding circuit, the stronger the bucking action of the series winding and lower the generator voltage, as the EMF induced in the armature winding of the generator depends upon the resultant magnetic field. At the time of short circuit, phi m and phi naught are nearly equal and opposite in action, and hence we know the resultant flux is negligible as well as the terminal voltage will drop to zero. Thus, the series winding helps in achieving the droop voltage ampere characteristic of the power source. Most of the generators for manual and automatic welding like SMAW and submerged arc welding are of the series opposition type normally. Next one is a split pole DC welding generator. In a split pole welding generator, a drooping voltage ampere characteristic is obtained owing to the effect of armature reaction. This generator is also called a bipolar welding generator, and this is employed manually for manual welding, mainly for manual welding. This generator has four main poles. Here we can see there are four main poles, and it has three sets of brushes riding the commutator. We can see there are three brushes here, one, two, and third one. As distinct from the conventional DC generator in which north and south poles are placed alternatively, in a bipolar generator the like poles are placed side by side, S1, S2, N1, N2. Two adjacent like poles may be regarded magnetically as a single pole split into two parts, hence the name split pole generator. The magnetic flux linking the poles may be divided into two parts. One part moves from N1. We can see here this is S1, this is S2, and here it is N2 and this is N1, isn't it? Right. So the magnetic flux linking the poles may be divided into two parts. One part moves from N1. This is the top one is the N1. It moves from N1 to S1. It moves here. The other one will travel from N2 to S2. This is the case. The magnitude of the EMF in the armature depends upon the densities of these two fluxes and how the denser the flux cut across the armature conductors. It will be depending upon the greater the EMF of the armature is. So the how much amount, I mean how the EMF of the armature is increased, or it is at increased level, that much amount of density of the flux will be there in order to cut across the armature conductors. The welding circuit is connected to the brushes A and B, and the field coils wound upon the magnetic poles are connected to the brushes A and E. When the arc is started, the current flowing through the armature winding sets up a magnetic field around it. The magnetic flux emerges from the armature core and it spans the airspace between the armature and the poles. A part of the flux enters S1, has its path through the frame S2 and the air gap in the armature core. The other part of the flux has its path through N1, the frame N2, and crosses the airspace, in which enter into the armature core. The path of the magnetic flux in the armature is shown by the dotted lines. We can see these dotted lines how it is entering from the north to the south poles. As we see, the magnetic flux in the armature winding moves with the magnetic flux in the poles N1 and S1 and against the magnetic flux in the poles N2 and S2. In other words, we can say the armature magnetic flux tends to build up the magnetic flux in the poles on one side and to kill it on the other side. The magnetic poles N1 are so constructed that they operate in conditions of magnetic saturation, and the addition of armature magnetic flux cannot increase it anymore, much as a saturated saline solution. You cannot dissolve any more salt, isn't it? Likewise, it will have the maximum magnetic saturation level. The magnetic flux of the armature, which opposes the magnetic flux in the poles N2 and S2, reduces this flux and in fact almost kills it. The alternating action of the main magnetic flux increases as the current in the welding circuit increases. A weaker magnetic flux in the poles, it will produce a low generator voltage. Thus, in the split pole welding generator, the drooping volt ampere characteristic is obtained by the bucking action of the magnetic flux of the armature winding, that is purely by armature reaction. Next, we can see about the output voltage ampere characteristics. We can see here it is drawn between the volt as well as the current with the references. So we can see when current increases, the voltage is getting dropped. Whatever be the value, the open circuit voltage clearly indicates that as the current increases, the voltage drop is very steep. This is in case of volt ampere characteristic in what is it opposition series generator case, as well as in case of a split pole type. Whatever it be the cases, in cases all these cases, the old Ampere characteristics is a drooping characteristics. And the last one is a multi-operator DC welding power sources. Here it is simple that there are two field windings are present. They are connected as a shunt field as well as the series field, and here we have more ballast rheostats. The condition is a multi-operator welding generator which has two field windings, one shunt and other one in series. They aid so that the magnetic flux of the series winding coincides in with that of shunt winding. In this case, the connection will be made. Because of this, the generator has a flat rather than drooping voltage ampere characteristic. It will be having a flat volt ampere characteristic. Hence, from a multi-operation welding generator, the current is taken to the bus bars directly, and from there it can be connected to a group of welders. We can see here there are in this representation itself we have three different welders. As power source has a flat volt ampere characteristic, the voltage across the bus bar will remain constant and is independent of the load. To obtain a drooping characteristic, the ballast rheostats are connected in series with the arcs at the scene of the welding operation. We can see here these are this ballast rheostats, right? Okay, the rheostat also serves to control the welding current. Most of these multi-operator sets produce a constant voltage of 60 volts and more. These welding sets take up less space than single operator units serving the same number of operators. Therefore, this type of plant is economical for installations where workers concentrated in one shop. They are also cheaper than the equivalent number of single operator sets. Actually, the maintenance will also be easier. In tapped reactor method, output current is regulated by taps on the reactor. This has limited number of current settings. In moving coil method, of current control, relative distance between the primary and the secondary windings is changed. When coils are more separated, I mean out of current, the out current will be less. The current output will be very less. In such a cases, we may go for the other methods. In magnetic shunt method, the position of the central magnetic shunt can be adjusted. This changes the magnitude of the shunt flux and therefore the output current. When central core is more inside, the load current will be less and vice versa. So these are certain problems which are carried out with the reactor methods, moving coil method and the shunt method. So rather than relying on the single sources, multi-operator DC welding generator has more number of advantages. Thank you.